So in this series of videos, we'll go through some research papers and attempt to answer the question whether getting a tattoo is safe. Just a warning, a simple answer, yes, tattoos are safe, or no, tattoos are not safe, doesn't exist.
What?
I know, I am almost as disappointed as you are. So instead, we are going to look at statistics, most and least safe colors, and things like that. So there are many factors that contribute to tattoo safety. Some of them depends on a tattoo artist, and some depends on you directly or indirectly. For instance, lack of aftercare can in extreme cases lead to death. So please take care of your fresh tattoo and remember that it's effectively a wound. There is also a third source of potential risks, and more about it later. The most common adverse effects are allergic reactions and sun sensitivity. Notice that allergic reactions can be triggered by sun exposure. So personally, I wouldn't overexpose tattoos to sunlight, especially colored ones. How about cancer? Well, no correlation between tattoos and skin cancer have been found so far. So what are the odds of you getting an adverse reaction then? When researchers talk about chances of getting an adverse reaction from a tattoo, they usually quote this paper. A nationwide survey in German-speaking countries, 3,400 people took part in the survey. The survey took place between 2007 and 2008, and it was found that 6% of participants reported persistent health problems. These problems included, for instance, intermittent edema, itching, elevated skin, etc. The key question is it really 6% or maybe the data is incomplete or biased in some way? The answer is both. The questionnaire was well designed, but still, it carries an intrinsic bias, even if only a slight one. We can suspect that the participants of the survey were slightly enriched with people who experience adverse reactions themselves. Moreover, the participants responded on a background of their own personal threshold of seeing the problem. For instance, the data regarding hygiene conditions under which tattoos were received were actually personal opinions. Participants were not professional hygienists. Also, please notice that for a person who follows hygiene standards, the chances of getting an adverse reaction will be probably lower than 6%. For instance, 3% of participants stated that their tattoo was done by an amateur. This does indicate lower hygiene standards, but also amateurs tend to use cheap inks or counterfeit inks. These inks tend to be much higher in impurities, and they can contain undesired substances. Also, a person can develop persistent adverse reactions as a result of improper aftercare. All of this can be avoided. The bottom line is, only about 1% of participants sought medical help, and about 2/3 of these people received medications. However, the data gathered by the questionnaire is incomplete. No one knows how modern tattoo pigments are going to behave and distribute in human body few decades after the injection. Such data does not exist. We know that tattoo pigments are mostly inert, but they are not 100% inert. However, daily dose of exposure coming from degrading pigments is said to be below detection limit of current analytical methods. So now is a perfect time to introduce more information about tattoo pigments. Coming back to the German study, you could speculate that the ink itself was more dangerous in 2008 because now the inks are organic. Well, first, organic pigments started to appear on market as early as the beginning of 90s, and secondly, the word organic has multiple meanings. So you think organic pigments are made without the use of artificial chemicals. However, this is what organic pigments are actually about. They are compounds containing carbon, to be precise, tetravalent carbon, that is, carbon that makes 4 bonds with neighboring atoms. And you may say it's all good because these compounds are chiefly of biological origin. Well, let me explain. All the compounds in you, in all living matter, plants, animals, are based on tetravalent carbon. Of course, taking water aside, that constitutes the majority of our volume. But the tetravalent carbon is everywhere, in proteins, sugars, fats, enzymes, DNA, etc. Now, there exists a number of compounds that are man-made, which are also based on tetravalent carbon. And if you compare the vast number of carbon compounds that are in nature to the number of man-made organic compounds, then of course the artificial organic compounds are only like a single water droplet in a sea. But these man-made compounds are the ones that are the most relevant for industry and medicine and even cosmetics. So organic compounds are, for instance, plastics, modern paints and printing inks, virtually all medications, for instance this is ibuprofen, And I guess I will explain to you this structure now so that you understand what the drawing represents. So carbons are on every vertex of the drawing. So this compound has 13 carbons and they all have to have 4 bonds each. So this carbon is okay. It has 2 single bonds and 1 double bond, which you count twice. So this carbon is fine. It has 4 bonds in total. If some carbon doesn't have 4 bonds, then you need to fill them in with hydrogens. Chemists don't draw hydrogens attached to carbon for clarity, with some exceptions, but we usually don't. So we have 18 hydrogens here. Another thing, organic compounds don't need to be safe. We all know medications have side effects, and even organic natural compounds can be deadly. So toxins in snake venoms are organic, drugs are organic. This is, for instance, one of the active compounds in cannabis. So how do I know which meaning of the word organic apply to the two inks? Because I looked up the SDS sheets, i.e. safety data sheets, which are on the ink manufacturer's website. SDS sheets has list of ingredients, so I looked them up, and organic pigments are man-made. So basically, some inks manufacturers and distributors take advantage of the fact that more people do groceries and know the word organic from that context than do chemistry, which I guess is slightly sad. At this point, you may wonder why we cannot go back to the inks used by indigenous people. After all, tattooing have been with us for thousands of years. So let's look at the development of tattoo ink. So as I mentioned before, more than organic pigments, there were inorganic mineral pigments. But I feel I need to talk about a third group. Organic pigments derived from living matter by indigenous people or ancient people. Because some tattoo-related companies want you to believe that they sell ink which has been prepared according to some ancient formula of something. Well, kurosumi is an example. On the bottle says Japanese ink. On the manufacturer website, they say that the ink was only originally formulated in Japan, whatever that means. But now they're made in US. Some distributors insist that it's Japanese ink made in Japan, and some even speculating about some kurosumi ancient recipe. And what is funny is that Barber DTS is a kurosumi licensed distributor. And by the way, if you look at the SDS sheets again, the pigments are no different to what is used elsewhere. So what are the chances that some ancient or indigenous tribe had a perfect tattoo ink formula derived from a living matter? In short, the chances of them having something that would allow for such high quality tattoos that we see nowadays are extremely low, and there are a couple of reasons for that. First, we want pigments, not dyes. We will say more about the difference later, but generally speaking, pigments are insoluble in water or fats, in contrast to most dyes. And just a side note, people from industry respect that difference a lot because it defines and limits applications of a certain colorant for certain industrial purposes, but others don't. So it really depends. I fully understand we all have different backgrounds, but for someone who is new to the topic, it does make everything confusing. And especially because dyes and pigments often share the same skeleton, if you like, and what differ are the R groups which might alter their solubility and hence the classification. So as I said, having pigments is crucial because otherwise the color would be completely washed away from the tissue. Then the pigment has to be resistant to visible and the UV light reaching the earth. Actually, the synthetic organic pigments used in the industry and in the modern tattoo inks are so-called high-performance pigments, and good light resistance is one of the reasons for that name. As far as I'm aware, overwhelming majority of natural food colorants do not fulfill the first or the second point, and often both of these points. But that's okay because foods don't have to have a long shelf life in the first place. Notice that I said overwhelming majority. That doesn't mean that there cannot exist a colorant that fulfill the two mentioned points. There is this interesting group of compounds called anthraquinone, widely spread in kingdom of fungi, which brings me to the point 3. The compound cannot be toxic or have toxic metabolites produced in a human body. For instance, anthraquinones synthesized by endophytic fungi protect the host plant from insects and other microorganisms, which might suggest they could be toxic at high concentrations, and with tattooing, we are talking about high local concentrations. Now, toxicity varies depending on the way of exposure, whether it's inhaling, digesting, or injection under the skin. And if we are talking about indigenous people, we also need to take into account that they didn't have laboratories, and it's very unlikely they would be able to isolate pure pigment. Most likely it would be a mixture of molecules, which leads to another point, that ink is not a vegetable stew. The composition needs to follow some rules. So ink is made of solid particles suspended in a liquid. Inks are colloids, and therefore, often there is problems with stability, which might lead to flocculation. What is flocculation? When the ink flocculates, the solid particles cluster together and they eventually sediment at the bottom of the flask, and so the ink is no more. Here we have an early example of the problem. The scribes in ancient Egypt needed ink, which was based on carbon black particles mixed with water. But this two-component mixture is unstable. The carbon grains were forming sediment, so Egyptians added Arabic gum, which stabilized the mixture. Notice that the points I mentioned are just a basic requirement for a good ink. Then the pigments have to have good color hue, brilliance, the ink needs to have the right viscosity, and the list can go on. Not to mention the very important modern requirement that the pigment cannot release toxic compounds during laser removal. So during laser removal, the laser breaks up the pigments into smaller molecules. These smaller molecules are taken up by macrophages, which then go to lymph nodes. The problem is that these smaller molecules can be toxic or even cancerogenic or cause allergic response. And please notice that I'm not saying that creating a set of inks with natural pigments is not possible. We're just not there yet. And if someone told me that they have some ancient formula for some tattooing, I would get very suspicious and ask a lot of questions. Okay, so let's go back to the diagram which shows the evolution of tattoo pigments. We have just said that the chances of some ancient civilization discovering a perfect tattoo pigments from organic matter were very low, and even if they did, such pigments most likely would not be suitable for high-quality tattoos. So let's just erase that. Inorganic pigments were the first widely known types of pigments that are colored minerals, that is rocks, mainly oxides and salts. To this day, only the first three are used. Then during 90s, transition to organic pigments took place. I will discuss the reason for the transition in the next video. This one is already quite long, and there is little more to it than just health concerns. One could even argue that health concerns were not the main drive for the transition. So now the tattoo industry uses synthetic, high-performance, organic pigments. Organic because they are based on carbon with 4 bonds. Here we see an example of a pigment first synthesized at the beginning of the 20th century. So that's all I have for you today. I hope you enjoyed the video and see you soon in the second video from the series. Bye!